The Amazon rainforest and the most advanced technology brought together in the same place. This is surely one of the most astonishing features of Kourou and its Guyana Space Center. Kourou is the spaceport of Europe. It's one of the most modern launch complexes in the world, and it's ideally located near the equator. This is going to be a direct broadcast, and you're welcomed here by the European Space Agency and the French National Space Agency. Kourou has long been associated with the name of Ariane, but the time has come perhaps to grow accustomed to a change in the number. It's from this Jupiter center that for the first time we will be able to see Ariane 5 on her launch pad. A new launcher requires new facilities. These now extend over 2,000 hectares, but we'll be coming back to that later. It is indeed a great moment. It's a premiere. It is the initial launch of a brand new version of Ariane that we'll be witnessing here with Ariane 501, because that's the name of the new version, 01 because this will be the first launch. But back now to the Jupiter building, because it will be here from the Jupiter Center that together with you and our guests, we will be witnessing this landmark event in the history of the European space industry. It is here in this control center behind the glass that all the data is being regrouped, and it's here that all the decisions are taken with regard to the phase that precedes liftoff. To make this live broadcast possible, and it's being beamed out simultaneously in English and French to both Europe and America, the services of no less than 6 satellites are being used, and in fact some of these were indeed launched by Ariane. After a lengthy preparation period, Ariane 5 is going to conduct its first mission in less than an hour's time. This is the beginning of the launch window. The launch window is the period during which the launch can take place. The beginning of the slot and its duration depend on the constraints of the satellite mission as well as the launcher constraints. H0 is at 8:35 local time. In other words, 8:35 or 13:35 in Darmstadt or in Paris, and we'll be having a satellite link with ISOC very soon. The slot will last 2 hours today on the 4th of June 1996, so it's from 8:35 to 10:35 local time. For this first launch, it was decided to have a daytime launch in order to ensure very good visibility and to be able to monitor the performance of the launcher on the first 60 kilometers. And now we're going to turn to our 2 guests who represent the French National Space Agency and the European Space Agency. Jean-Marie Luton, you're Director General of ESA. Welcome to the CSG. First of all, I would like to express my great satisfaction to be here in Kourou today at the Jupiter Control Center. And I'd like to greet all those who here in Kourou and in Paris are going to follow launch operations. I would like to greet particularly Mr. V088, who is Minister for Scientific Affairs and who is Chairman of the Council of Ministers of the European Space Agency. Everywhere and in Europe particularly, thousands of people are going to follow this great event during the video broadcast. In Paris, in the various facilities of the European Space Agency and the French National Space Agency, among the industries who participate in the development of Ariane. I'd like to welcome all those who, as I, will witness this great event, although we might be slightly tense at this moment, but it's the culmination point of more than 10 years of continuous efforts. The mission to develop Ariane and to put in orbit cluster satellites, which will teach us about the interactions of the Earth and the Sun. I would like to join my friend Jean-Marie Luton to welcome everybody who is listening to us.
I would like to tell everybody that we're here at the Guyana Space Center. The Guyana Space Center will be introduced to you by the director, Mr. Michel Mignot, later on, but I'd like to thank the Guyana Space Center for the remarkable organization we are benefiting from. And I'd like to remind you that the French National Space Agency plays an important role in this program as we are a main contractor. I would also thank the director of launchers, the director, Mr. Daniel Meunier, who plays a fundamental role in the implementation of this program, and it's a very great day.
Thank you, Alain Bensusson. We're indeed about to discover Guyana, which is a French département located in the northeast of Latin America. And with some shots provided by the local tourist office, well, we're going to go off on an excursion.
Exigez consommer local, il n'y a pas de problème, consommer local et buvez frais et bien fraîche. C'est-à-dire buvez une glace au sirop d'un fruit du pays, donc le fruit de notre très chère Guyane. Pays du soleil, bien ensoleillé, Guyane, terre spatiale.
Michel Mignot, as you see, this is a land of adventure, but it's also the space venture. It's the alliance of tradition and modernity.
Of course. First of all, I also would like to welcome you to the Guyana Space Center, the European Spaceport, for this great event, the first launch of Ariane 501. As you have said before, we're here in Guyana, where space activities take place. We're very happy to be here in Guyana in this beautiful French department in Amazon territory in Latin America. The space activities have transformed the image of this region, giving it not only its traditional image, but also, due to the riches, a technological activities for the future. Now, technology rhymes with Ariane. Here, space activities represent 50% of the economy of the department, 30% of jobs, and that's quite considerable. With Guyana, we hope that activities besides space activities develop more and more. Tourist activity, of course, but also activities for industries who can benefit from this wonderful place, who can benefit from this alliance between Latin America.
Everything is going well as far as the operations go.
At the very moment, at T-minus 50 minutes, operations are nominal, as we say in our jargon. And we have some worries, however, about the weather conditions, but we'll have a weather report at H-minus 30 minutes, and then we will decide whether we have to wait a bit to see some blue sky to launch under wonderful conditions. We will hear this in a few moments from now, and whether we have a slight delay or not. But as far as launcher operations are concerned, the first stage is being filled up. The launch range is nominal. Everything is nominal.
Thank you, Michel Mignot. During this broadcast that's going to last 2 hours, we're going to go to several places. In a few minutes, we're going to go somewhere else here in Kourou, and then after that, we'll go to Paris. But for the moment, we're going to Germany, to ESOC. Pete Smulders.
Yes, I'm Pete Smulders at the European Space Operations Center in Darmstadt, where the European satellites are being monitored. Let us briefly switch to Mike McKay in the main control room. Mike, how are things at the moment?
Thank you, Pete. This is the Mission Control Center in Germany, in Darmstadt, and here we have the A team on shift. They've taken over from the B team, who's preparing the whole control center. So far, everything looks good, and as you heard earlier, this is the nerve center of the mission control. As you can see on the screen, we have the full flight control team on position. This is only part of our team. The rest of the team, who's an industrial support team, are sitting in the next room to provide us expertise in the event of something unforeseen happening. And also we have flight dynamics, who will be calculating all the orbits and producing the maneuver commands that will take the 4 spacecraft into their elliptical orbit. So I've heard on the voice clips that so far everything is green. The status looks good. I've seen also on the board just above me here that all the greens for the ground segment show that everything is in order. And I must admit, the atmosphere here for such a large event is, how should I say, excited and well tempered with the professionalism that has brought Europe to the stand that it is in the space business today. So I think we go back to Kourou at this point, to Martin Ranson.
Yes, thank you very much. The situation here, we have a cloudy, overcast sky. Just to situate things geographically, we're about 10 kilometers from the technical center. A technical center, Philippe, as you know, where all the buildings have the names of the planets of our solar system. All the viewing sites outside around the spaceport bear the names of birds. The most famous of the birds in French Guiana is the toucan, with its large, outsized yellow beak. And our viewing site of Toucan is perhaps one of the most privileged positions. It has a magnificent panoramic view. We have in front of us the final assembly building where Ariane was until yesterday morning. Slightly to the left, we have the launch pad with our launcher surrounded by the 4 lightning masts. Again to the left, nearer to us, we have the vehicle integration building. And then just behind to the left, we have the service gantry and the umbilical tower of the Ariane 4 launch pad. And hidden behind the gantry, there is an Ariane ready to lift off in a few days' time. Some 350 people have come from Europe and from other parts of the world to participate in this event. About 100 of them are assembled here with us at the Toucan site. But there are also the people who are at the other sites, those sites with those bird names of Kikiwi, Colibri, Agami. People at Carapa as well are all awaiting this event with much anxiety, perhaps, and anticipation. The weather situation is going to be a primary consideration, and as I said, the sky is still overcast, and we're hoping and crossing our fingers that there will be some clearings during this 2-hour window.
Well, we too are making the same wish in Jupiter here, to follow this broadcast that's going to last for a little bit less than 2 hours. We have 2 technical consultants. We have, first of all, Juan de Dalmo from the Launcher Directorate of ESA, and who on several occasions was range operations manager. And now we have 2, Pierre Marx, Quality Director at CNES, and who's always been a member of the team working on Ariane 5 from the beginning. With you, Juan, we're going to discuss something that's very important that Martin Ransom already touched upon briefly, and that is this idea of a meteo green signal, status signal. It's as if you had a number of keys and you have to open them.
It's a nice way to present it. In fact, we are right now quite a few hundred people participating at this moment to the countdown, certainly more than 500 people. And the status of the systems they are monitoring is summarized in this panel. We could try to describe it from top to bottom. First of all, authorization to launch is given by the operations manager here in Jupiter and his team. Secondly, The launch complex, about 14 kilometers from here, is monitored by a team in the launch center in the blockhouse over there, and they are sending us green right now. Thirdly, the launcher itself certainly has to be also go for liftoff in 44 minutes now. Next is the spacecraft, the 4 cluster spacecraft being monitored by the team partly here in Jupiter Mission Control, partly closer to the launcher, and of course in Germany, which monitors all the network of stations around the world. They are all green, as you can see. Meteo comes next, weather forecast, and we'll have the occasion of coming back to this. And last but not least, the status of the launch base or launch range, which includes teams located in different sites as well and monitoring logistics. This stands for energy and air conditioning distribution, flight safety, telemetry, tracking, and telecommunication links. And we will try to describe each of these systems later.
Max, you were a member of the original team working on the Ariane 5 project. What's your impression, and what's the impression of your team when you see it ready to lift off in 43 minutes and 30 seconds?
Well, this is the culmination point of 10 to 15 years of work. I had the honor and privilege to start the first considerations of the design of the launch vehicle. When the first Arianes had been launched, we were already thinking about the future launchers. The economic and industrial issues involved with space became confirmed, and we had to look into the future. And the future is today now. So this is why the first Ariane family, which led to Ariane 4, gave us a stimulus to design a totally new launch vehicle. This new designed vehicle will fly today.
Now I propose we discover together a film sequence that will show us the inside of Ariane 5.
Ariane 5 is based on a quite different design concept to the earlier versions of the launcher. Overall responsibility for the program lies with the European Space Agency ESA, with the French Space Agency CNES performing executive management functions. Aerospatiale is acting as industrial architect. The power needed to get Ariane 5 off the ground is delivered by 2 large solid boosters, and these in fact impart the bulk of acceleration during the first 2 minutes of flight. Thrust is also provided by the Vulcain engine, a single new generation cryogenic propulsion unit. The Vulcain engine, its flight control system and its tanks make up the cryogenic main stage. Lastly, the upper stage places the payload in the required orbit. The stage is housed in the vehicle equipment bay, which can be regarded as the launcher's brain. The satellites are accommodated in the Speltra multiple satellite carrier structure and in the fairing, whose diameter is substantially greater than in the case of Ariane 4. The design of Ariane 5 makes it suitable for all types of mission.
Can you tell us what the reasons were and what the objectives were when the specifications were set out for Ariane 5?
The specifications were decided, as Mr. Luton mentioned earlier, the ministerial conference of the European Space Agency. 2 important conferences took place back in 1985 and 87, where it was decided to start with the development of this new generation of launchers in Europe. This Ariane 5 launches had at that time and still have today the following drivers. First of all, to assure continuity of access to space for Europe and for the rest of the world. Secondly, to have a more performant launcher to adapt it to the increasing mass and volume of satellites. Then to have a more reliable launcher, and I hope Pierre can tell us more about why it is more reliable. At the same time, a less costly launcher, and also to be compatible with manned flights.
What were the technology choices that allowed you to attain these objectives?
Well, first of all, we took into account these three imperatives that Juan has just mentioned. We established the specifications for the launch vehicle to launch twice 3 tons into geostationary orbit, to have a reliability of over 0.98% and a simpler system than Ariane 4. To do this, we chose the following. To lift off and to get out of the atmosphere as quickly as possible, we chose the high thrust that solid propellant boosters allow for. And these 2 lateral boosters provide for this thrust. To arrive at the velocity that is necessary for the payload to get into orbit, that's done by the central cryogenic stage and the Vulcan engine. This engine is ignited on ground and it is checked out before the boosters are ignited. Thus, the reliability of the launch vehicle is increased. In order to place the payloads in orbit, we have a small storable propellant stage which allows Ariane to place satellites in geostationary transfer orbit.
We're now going to discover something that will give us an insight into the operation of the main cryogenic stage, the EPC.
Cryogenic main stage is manufactured by Aerospatiale. Its tank is made up of cylindrical sections and has a diameter of 5.4 meters, equivalent to that of an Airbus A300 fuselage. The tank structure has been optimized, a particular feature being a common bulkhead separating the oxygen and hydrogen compartments. The tank is produced by the Cryospace company, a joint subsidiary of Aerospatiale and Air Liquide. The Vulcan engine, developed by SEP, is the core of the entire launcher. Following a large number of tests on 2 stands, one located in France and the other in Germany, the engine has now gone into series production. From the time of the first tests through to qualification of the complete launcher in French Guiana, Vulcan engines have clocked up total running time on the ground of over 87,000 seconds, equivalent to more than 150 engine flights. Thanks to the decision to test the stage on the actual launch site in Kourou, it was possible to qualify the main stage and the associated ground facilities at one and the same time.
Let's now discover the solid booster stage, the 2 boosters that are fixed laterally onto the main cryogenic stage.
The boosters contain the largest solid rocket motors ever built by European industry. The boosters are assembled and filled in Guyana by Euro Propulsion, a joint subsidiary of BPD and SEP. Each booster is made up of 3 segments measuring 3 meters across. The 2 larger segments are loaded in a purpose-built propellant plant in Guyana. The forward segment, the smallest of the 3, is loaded with propellant in Italy. And in Guyana, the igniter is fitted to the top of the booster. To qualify the boosters, 7 test firings were performed on a dedicated test stand in Guyana.
Last of the 4 engines is the storable propellant stage.
The upper stage, developed by Daimler-Benz Aerospace, is the only stage to be ignited in flight. It's powered by storable propellants, some 10 tons of oxidizer and fuel being carried in 4 tanks. Thrust is supplied by a reignitable engine which operates for about 20 minutes. The engine has come through a large number of static tests in Germany.
The launcher needs a brain. That's what we call the equipment bay, and we'll now discover the equipment bay.
The ring-shaped vehicle equipment bay encircles the upper stage. Developed by Matra Marconi Space, the vehicle equipment bay houses much of the launcher's electronics, including the guidance system, onboard computers, and the launch command circuits.
The last two components are the spelter and the fairing right at the top of Ariane 5.
To enable several satellites to be launched in the course of a single mission, a special structure known as the spelter has been developed by Daimler-Benz Aerospace. The lower payload is encapsulated in the spelter, the upper payload being installed inside the fairing without any special support structure. The fairing, developed by Oerlikon Contraves, protects the payload during flight through the atmosphere. Jettisoning of the two half shells that make up the fairing has been tested in a vacuum chamber in the United States.
Jean Grenier, you're Director General of Eutelsat. Between Eutelsat and Ariane, there's a long history because there have been at least 14 contracts placed by Eutelsat for an Ariane launch.
Yes, this is quite true. Quite personally speaking, I must say that I'm following this event with great emotion. 20 years ago, the French government asked me to convince Intelsat to buy the first two Arianes. I wasn't terribly convinced at the time. 20 years later, I was very impressed. Today, I'm customer, and if you want to know what a customer thinks, well, the point of view of a customer is very simple. You have three elements that interest us. Availability, that is the possibility to launch when you need to launch. The cost and reliability. Ariane 5, from the point of view of availability, for us has a great advantage. We have spacecraft that weigh 3 tons, the instrumentation, and the joy of finding a partner ought to be easier for us. There is no doubt that reliability theoretically is perfect, and we trust the development team. And as far as costs are concerned, we have spoken of 10% cheaper. We have 4 contracts today with Arianespace. Arianespace are going to choose whether it's an Ariane 4 or an Ariane 5 we travel on. What's the advantage if it's an Ariane 5? Well, there are 2 of them. One, we will be saving the insurance cost for the launch vehicle because of the high reliability. If there is a failure, Arianespace replaces the launch vehicle. And secondly, for the same price, we can certainly achieve a longer lifetime as we can take on more fuel on board. Thank you.
Thank you, Jean Grenier. We're back to Martin Ransom, who has a guest with him.
Yes, and another kind of guest, totally different kind of guest. As you said, the main objective of Ariane is automatic missions for satellites, but there are also astronauts involved. One of those astronauts is with me, Jean-Pierre Aigneret. Jean-Pierre, you are well known for your Altair mission in the summer of 1993.
Before we speak of Ariane, I'd like to put you a question. Were you able to see Kourou, the European spaceport, from orbit? Of course, that's a reflex of a pilot to look at the landing sites and the starting sites from space. And obviously, from up there, it's a privilege to look down to Kourou. You see the Amazon, you see the spaceport, and you see that something magic is happening down there. Is it true that most astronauts are particularly concerned with the development of any new launcher, considering they may need it to get into space? Yes, of course. I joined CNES in in '85 when the Ariane 5 program had just been decided, and I have particular emotion when I see high technology concentrated in such a small volume. Manned spaceflight, which was envisaged right from the outset with this launch vehicle, must take into account a number of aspects. We must also find a compromise between the vehicle and the launch vehicle, and this is a vehicle I was particularly interested in. The manned spaceflight is not so far away then, is it? When we consider that the second qualification flight 502 is not so far away. That's how we can put it, yes. 502 will not be a manned spaceflight, but there is an element on it that can let us judge of the maturity of the European space program. The day we have not only a technological payload under the fairing, but also human beings, a human crew, then we will have reached a full maturity. We'll come back to you after liftoff, but perhaps we can put a last question. When you're on a launch pad such as this one, does that remind you of your departure from Baikonur? It's quite something different. It's either being on the scene or in the audience. It's an important event for myself. I'm very moved. I've been working on this project with many of my friends. It's a project of utmost importance. It's a human project, and it has enormous importance for Europe.
Thank you very much indeed, Jean-Pierre Agnew. We'll be meeting later on.
The European Space Agency is one of the two institutions implementing this project for European launcher, and with Fredrik Engström we'll be discussing the role of ESA.
The European Space Agency has 14 member states, and almost all of these member states participate in the financing of the Ariane launcher family. The latest version of Ariane is the Ariane 5, and it's also by far the biggest development in space that Europe has ever done. The European Space Agency is a development organization responsible for the overall development of the Ariane 5 program. The technical execution of the program is delegated to the French space agency CNES, and finally the commercialization of the launcher, selling it to customers all over the world, is given to Arianespace, a private company. The Ariane family of launchers guarantees Europe's free access to space. And in fact, it has also been Ariane that created the so-called commercial launch market, the possibility for anyone to buy a launcher and send up a satellite.
Well, given the substantial commitment of France to this program, it's the CNES, the French space agency, that has industrial responsibility.
The French National Space Agency devised the project, defined the architecture of the launch vehicle, chose the industries, and also defined the contribution of various European countries participating in this program. For Ariane 5, we have new dimensions. For one, in previous program, we were building on what already existed. Ariane 5 is completely new. We created everything, taking into account the volume of the program. This responsibility was considerable. It represented sometimes half of the budget of the European Space Agency. The budget was managed by CNES. This also meant for France a considerable contribution in respect with the total budget of the agency.
Francis Avanzi, you're Director General of Arianespace. After the second qualification flight, 502, it will be up to Arianespace to take over the operations of Ariane 5. Are you ready for the transition?
Of course we're ready. You know that the teams are joint teams between ESA CNES, and we are ready to take over the exploitation of this beautiful vehicle and to win the race for Europe. We mustn't forget that Arianespace has more than 50% of the civilian launcher market. Is Ariane 5 the tool you absolutely need? Is it adapted to the market? First of all, we must define the market. I would tend to define 8 criteria, but Mr. Grenier has already quoted 3 of them. Obviously, the mass of the satellites, masses of spacecraft are increasing. The volume of spacecraft, Ariane 5 can propose 130% more than Ariane 4 volume, which allows you to save on the size of the spacecraft, antennas, etc. We also ask for more capacity. You know that 70 satellites are to be placed in orbit by 99, and Ariane 5 will be produced at a rate of 8 per year from 2000 on. Reliability, Mr. Grenier mentioned this. Now, flexibility. Mr. Grenier mentioned the need for availability. Obviously, the operators, the customers, want to have their spacecraft in orbit, in operation, as soon as possible after their order. We have accepted a challenge accepted by European industry to reduce manufacturing cycles by 50%, 24 months rather than 46. As far as services go, we will ensure the continuity of service. It will be guaranteed with the Ariane 4 backup during the transition phase. Will be guaranteed also by possibilities of booking right now over and beyond the year 2000. As far as the evolution is concerned, it's up to us to adapt the product to the needs of the market. To do this, Ariane 5 will be more than a simple launch vehicle. It's going to be a family in itself, allowing for Europe to access space independently, but it will also allow Arianespace and Europe to remain the leaders on the market with more than 50%.
Thank you. And we're back to our 2 technical consultants to have a summary of the situation.
Sur le critère de visibilité de la trajectoire lanceur jusqu'à la séparation des accélérateurs à poudre. À tous de l'EDO, le décompte s'arrêtera automatiquement à H-7 minutes.
Yes, one could have expected this, and in fact, the night has been quite cloudy here in Kourou. We had rain last night, and it is right now raining on Devil's Island, where a special telescope that has recently been installed to track the launchers cannot send us the pictures we were expecting. Its cover had to be closed again because of the rain. So as the range operations manager just announced, we continue countdown until -7 minutes. On the other systems, perhaps I could say quickly that the telemetry checks. The launcher is already sending the telemetry it will be sending during flight, and as many as 5 channels have been checked and are being recorded in the telemetry station close to Jupiter. This is quite specific configuration because instead of 1 telemetry channel, Ariane 5 for this first flight is sending 5 channels right now from the 2 boosters, from the main stage, and also from the vehicle equipment bay. The Kourou telemetry station receives this data and also the data from the downrange stations. We will come back to that.
Mike McKay, what's happening at ESOC?
Okay, we're back in the main control room. I have here with me Gustav Mecke, who is the project coordinator here at ESOC, and he's also been involved in discussing with the team in Kourou what's been going on. Gus, how's it been going at Kourou?
I must say excellent. Everything went according to the plans. The teams worked in collaboration together, the people from industry and our own people from ESA, from ESTEC. And everything is green on the spacecraft. It's perfect. Everything is nominal. So I'm very happy and very pleased.
You're not only in coordination with the people in Kourou, but you also have an industrial team here supporting you. How is they handling the countdown?
That's right. We have also, for the support of the ESOC operations now and for the first couple of weeks after launch, industrial people and people from ESTEC here. We have had training sessions, lots of training sessions with the ESOC. Everything is very well prepared. Everything is running very, very smoothly. We are therefore going, and let's keep the fingers crossed.
Great. Okay, we go back over to Juan in Jupiter 2.
Martin Ransom, from where you are, you can see a few clouds, I would imagine.
Yes, in fact, the situation is pretty bleak, but we did have a situation that was similar yesterday, where during the launch window between 8:35 and 10:35, there was considerable rain and an overcast sky, but as I understand it, towards the end of that window, there was a very, very short clearing, which would have enabled us to allow a liftoff. So I think one can keep a certain amount of cautious optimism, but at the present time the sky is pretty cloudy and it doesn't look too optimistic.
The arrangements devised by the French space agency CNES for transporting to Kourou the various launcher components supplied by some 150 firms from 12 different European countries are necessarily complex. The main stage was transported up the Seine from Les Mureaux to Le Havre, where it was loaded on the Toucan. At this point, the upper stage had already been loaded in Bremen and the fairing and Speltra in Rotterdam. At each port of call, the various elements making up the complete launcher thus took their places in the hold and on the bridge of the Toucan, the only exception being the boosters, which are assembled in Kourou. From Pariacabo, the port of arrival in Kourou, the launcher parts were transported to the Guyana Space Center. This marked the beginning of the launch campaign. In the course of the campaign, the cryogenic main stage is erected in the launcher integration building and then positioned over the launch table. The vehicle equipment bay is mounted on the upper stage. The storable propellant stage is installed on the vehicle equipment bay. The assembly is then attached to the two boosters following their transfer from the booster integration building and placement on the launch table. Once mechanical assembly has been completed, the various electrical and fluid connections between the stages and with the launch table are established and tested. The launcher countdown rehearsal for Flight 501 took place on the 24th of April. This involved transferring Ariane 5 to the launch zone for a trial run of the different countdown phases. The launcher was then transported back to the final assembly building, where the satellite campaign was by then drawing to a close. The next steps in the assembly sequence were for the Speltra containing two of the cluster satellites, the two other satellites, and finally the fairing to be fitted to the launcher. At this point, Ariane 5 was ready to be launched, all that remained being for it to be transferred to the launch zone.
Let's remind you that the upper stage was filled in the assembly building. We have Mr. Pierre Perez with us here. You are a member of CNES and you have supervised this campaign. It was a rather lengthy campaign. It started in February, if I recall correctly. During a long campaign, a lot of incidents can happen, but that's normal for a first campaign. Yes, this was the development campaign for Ariane 501. As far as verifications go, the normal checks are all carried out, but for this very first campaign, we tested the equipment under extreme conditions, and we made sure that under extreme conditions, the performance required of the launch vehicle for flight were nonetheless guaranteed. Hence, the checks lasted longer than they should. We furthermore carried out a launcher systems rehearsal. This rehearsal corresponds to a dress rehearsal of the launch countdown. It was absolutely necessary to do this in order to validate the procedures and the software in a configuration as close as possible to the launch countdown. So this is why this campaign was a rather lengthy one. We needed 83 working days for this countdown. Do you have the ambition to do things better for the second flight? Yes, for 502, we intend to have a campaign of 50 working days. And after that, the operational teams consider that after 10 launches, we will be able to find a figure of 22 days for the launch campaign. Thank you, Mr. Pierre Perez. The marking event during yesterday's day was this beautiful view of the launch vehicle being rolled out of the assembly building. 500 tons moved slowly towards the launch pad. Let us look at the pictures, and this happened yesterday morning. Ariane 5 is a program that includes 12 countries. A lot of experience was gained in the space industry, not only for launch vehicles, but also spacecraft. We learned how to work together to bring different cultures together so that this becomes a dialogue. Today, the development work, verification of the compatibility of the launch vehicle with the spacecraft has been carried out. All tests were carried out. All files were completed. And we are extremely confident in the success of the launch vehicle. Obviously, there will always be improvements necessary, but the main job is done. Every day is a new adventure in the preparation of this campaign. But to see the launch vehicle out and moving towards the launch zone is really extraordinary. It's the climax of a long waiting period. We hardly dare to believe it all.
And some 10, 11 minutes to count down with that hold that has been announced for the -7 mark. The weather situation still hasn't improved here in French Guiana. Perhaps you have more details at the Jupiter Mission Control.
What about the weather? No additional information, as Martin Ransom was supposing?
Unfortunately, not. We can perhaps recall what this weather criteria are to authorize liftoff. First of all, the wind has to be slower than 10 meters per second, which is 36 kilometers an hour during flight. Of course, the launcher, as long as it stands on the launch pad, is protected by different systems, a deflecting tower and also a wind damper. Second criteria is the risk of lightning during flight, and several sensors are installed to measure the electric fields. During the waiting phase of the launcher on the ground, it is protected from the lightning by these 4 tall towers. And last, the visibility of the first part of the trajectory has to be cleared and guaranteed so that the telescope on Devil's Island can track up to about 90 kilometers distance from here, where the separation of the two solid boosters takes place, and this is a specific requirement of this first launch.
Pierre, qu'est-ce qui se passe côté lanceur?
What's happening on the launcher?
The launch vehicle is ready. It's ready for the automatic sequence at -7 minutes. Unfortunately, the weather conditions prevent us from continuing the countdown. For the moment, what we can say that is that the launch vehicle is filled with liquid hydrogen and liquid oxygen, 155 tons. We're also pre-chilling the engine, and you will see the hydrogen coming out of the nozzle. This hydrogen is used to chill down the pipes and the valves to these conditions. During this time, the launch vehicle is filled from the ground.
What do we see here? We have the impression that these are flames. What is happening here is it's called
Je confirme qu'il y aura un arrêt des comptes à moins 7 minutes pour raison météo, critère C2 rouge, suivi d'un rouge cluster qui a besoin de 4 minutes avant la reprise du décompte pour programmer son séquenceur de vol.
Donc Pierre, on revient après cette annonce importante du...
After hearing that important announcement of the Range Operations Manager, let's come back to the screen for a moment.
Donc c'est Ariane 5 sur sa zone
This
de lancement,
is
prête.
Ariane 5, ready on its launch pad.
Là, nous voyons effectivement ce que je disais tout à l'heure.
What we see here is what I mentioned earlier. The hydrogen is being burnt in what we call the hydrogen pool. It's burnt in order to avoid explosive strata.
Yes, perhaps a little explanation on what the Range Operations Manager just said on the paging here. He mentioned the C2 criteria being read, and this corresponds to what we were telling about lightning risk in altitude. The C2 criteria has to respect a minimum of electric field that is being measured, and this is also not respected. So in fact, this Meteo red status is double.
À tous les arrêt des comptes, tous les moyens sont en configuration H-7 minutes, rouge météo critère C2, rouge cluster pour programmation du séquenceur de vol.
Visualize, the familiar sun seems calm, even deadpan, but its atmosphere is hot and stormy. The sun's visible surface is agitated and racked by explosions, and non-stop streams of charged atomic particles race outwards in the solar wind. Far away, the sun's rays bring life to the planet Earth and drive its weather. But a different kind of weather comes with the solar wind. Auroras glow when solar particles hit the air around the Earth's magnetic poles. To find out exactly how the solar wind affects our planet is the task of the Cluster mission. Many previous spacecraft have probed the streams of particles that dance like invisible auroras all around the Earth. Cluster is unique in operating 4 satellites together. Why 4? The ever-changing patterns of activity recorded by a single spacecraft leave scientists perplexed about what's happening. A pair of satellites can start to make sense of changes in activity. For a rough impression across a slice of space, 3 would do. But to see the particle streams and fields clearly in 3 dimensions, you need 4 satellites. When the solar wind reaches our neighborhood, the Earth's magnetic field prevents most of the solar particles from reaching our planet. but some break through the magnetic defenses. Cluster will tour the battlefields where magnetism and the solar wind fight for control of the Earth's surroundings.
À tous les vidéos pour information sur la chronologie, les conditions météorologiques semblent s'améliorer. Dans 15 minutes à partir de maintenant, la décision sera prise de poursuivre la chronologie ou non. Tous les moyens se tiennent prêts dans la configuration. Moins 7 minutes ont passé.
The problem of preparing 4 identical spacecraft. This required virtually a production line with different teams working in parallel. Every one of the 4 spacecraft is essential for the mission's success, so the construction was like giving birth to quadruplets, and each cluster spacecraft, like a baby, required 100% care to make it fit for a mission in space lasting at least 2 years. Cluster's orbit will enable the 4 satellites to explore the cavern in space created by the Earth's magnetism. Examining their signals, Cluster's scientists will look for the entry points where particles from the sun infiltrate through the magnetic shield. Do they break in through the front door? And do they come in stealthily or in a rush? Apparently some of the solar particles slip round to the back door and then blast their way in. How do they manage that? Others battle for admission at weak points in the shield over the Earth's magnetic poles. It's an electrical puzzle laid out across thousands of kilometers of space, and each satellite in the cluster is a state-of-the-art electrical laboratory. All the cluster satellites carry the same instruments. Working as a team, they should answer questions about the Earth's space environment that have baffled scientists for many years.
Attention pour reprise du décompte. Top. À tous les vidéos, le décompte est repris. Nouveau H0 visé. 12 heures, 33 minutes, 59 secondes, temps universel.
Juan, on voit à nouveau le décompte.
Once again, we've resumed the countdown. We're now at 6 minutes 37 from the liftoff. So we're now into the automatic sequence.
Yes, this is correct. We are within the synchronized sequence now, and very soon the operations manager will switch to automatic status transmission. This means that any problem occurring in any of the systems during this sequence would automatically bring the countdown to a hold. This is done because there are such a great number of checks and commands being sent to the vehicle that manually one could not perform this with enough reliability. Still, though, there is a separate system of manual interruption of the countdown. This means that human beings can still override the computers in case of a major problem.
The red status meant that there had to be held before the final sequence. What happens if there's another cloud and there's another red status
well,
signal?
the meteor status is not included into automatic transmission because this sequence is only started if the weather forecast guarantees the respect of the 3 criteria for a period of time which is long enough to cover for the whole synchronized sequence. So there is no short notice meteor red to be expected.
Pierre,
4 minutes 40. And I think it's important to explain what's going to happen with the Vulcan engine in particular.
First of all, we're still in the preliminary phase of the automatic sequence. We're configuring the launch vehicle for the last and final phase when the launch vehicle is ready for ignition. At 4 minutes, we're going to pressurize the liquid oxygen tank of the central stage, and then the hydrogen tank. Then at H-1 minute, we move on to onboard power. Until then, the launch vehicle is powered by ground facilities, and then at minus 30 seconds, the deluge in the jet deflectors of the central stage and the boosters is started, and then flight control is started, the servo actuators that govern thrust vector control at H0. 3 seconds before H0. Ground hands over to onboard. It will be the onboard computer that commands startup of the engines and also commands liftoff. The engine is ignited and then it is checked out. The engine starts by opening a valve. The propellant enters the combustion chamber. At the same time, the gas generator is started up. That gives the turbines hot gas. It spins up the turbines and the pumps. And then the pressure establishes. And at 6.7 seconds after H0, we check out the chamber pressure. In that case, the onboard computer commands ignition of the boosters, and around 8 seconds after H0, they lift off.
It's important to mention this deviation between H0 and the real liftoff of Ariane 5. Yes.
H0 corresponds to the opening of the feed valves of the Vulcan engine. Only 8 seconds later, we will see liftoff of the launch vehicle.
There's another piece of information I'd like to have, and that is the flight sequences, so that we know what's going to happen afterwards, because of course we're at minus 2 minutes, so we have to be very quick. A couple of figures.
There are 4 phases. The powered phase that brings you out of the atmosphere, that lasts 2 minutes. Second, the continuation of the flight with the EPC until 10 minutes. When all propellant is consumed, then the EPS is ignited, the storable propellant stage, and then the satellites are oriented. The flight will last about 30 minutes.
1 minute and 25 seconds. And you see people leaving the Jupiter Center to see this.
À tous de l'EDO. Attention pour H-1 minute. Top moins 1 minute et des comptes.
Nous sommes à 56 secondes du premier vol d'Ariane 5 qui emporte.
We're about to see the liftoff of Ariane 5 that has on board 4 cluster spacecraft.
À tous de l'EDO. Attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage. Tous les paramètres propulsifs sont normaux et la trajectoire est normale. À tous les moyens restent à leur poste.
You will have understood this is an enormous disappointment. Michel Mignot, who is director of the CSG, will now make an official announcement.
For as yet unknown reason, the launch vehicle exploded in flight 4,000 meters height after liftoff, and the fragments fell back in a zone that was protected. I can reassure you there is nobody in these protected areas. Links with all personnel and outside sites have been activated. The intervention plan will start up in a few moments. The prefect is in the emergency room, and I will go and join him when I finish this declaration. The teams are going on the site and will save all sites. The invited staff on the Toucan site are being evacuated in a safety zone that is foreseen for this purpose. Guests on the observation sites Kikiwe and Colibri have already left in the buses towards Sinamari to get away from the impact zone. They wouldn't have been implied in any case. The personnel of Karapa is invited to return to Kourou. They risk nothing. They can come back to Kourou calmly. When every risk is discarded, people remain in LR2 and LR3 on their post. You listen to RFO or listen to the CSG journal. You will be informed constantly. In 30 minutes, I will give you more information. I would like to reassure our guests and the population for unexplained reasons. The launch vehicle exploded, but there is no reason for our guests or the staff on the site to be worried about this.
Marie Luton, Director General of ESA.
I would like to speak on behalf of all that the first launch of Ariane 5 was not capable of validating this launch vehicle. It was our first test flight, an entirely new launch vehicle. Each element was tested on ground in the past years and months. It's an entirely new design. This launch vehicle uses engines that are 10 times more powerful than Ariane 4. Its electronic brain is 100 times more powerful than the one used on Ariane 4. Many qualifications, reviews, flight tests took place in order to confirm the choices made. There is, however, no filter ensuring absolute guarantee. Only flight tests with real environmental conditions of the launch vehicle can demonstrate its capacity. A second test flight is foreseen in the development plan. This test is due in a few months from now. And before that, everything must be done to understand this failure and to contribute the modifications for this second test to be successful. An inquiry board will be established in the coming days. This inquiry board will have to submit a report before mid-July in order to establish the causes of the incident, in order to find the modifications necessary to avoid another incident. Ariane 5 is an important element of Europe in space. The determination and the solidarity of all political, technical, industrial authorities allow Ariane to be confirmed in its final success. So on this.
We now have a link. Or we should, in a few moments, have a link with Paris, where we'll hear the reaction of the French Minister, François Fillon.
Voici qui apparaît sur nos écrans.
The first flight of Ariane 5 was an experimental flight. Jean-Marie Luton said so. It was a matter of testing in flight an entirely new launch vehicle. In the history of European space, in the history of space exploration, the first experimentations, the first flights often have been the victims of incidents. The inquiry board will tell us what the reasons for this incident are, but I must reassure all engineers and all technicians of ESA, CNES, the CSG and industry that we trust them entirely. We know exactly which risks we run with the first event. As Jean-Marie Luton just said, Ariane 5 is an important element of success of space in Europe. For us, it means the certainty to preserve our first place in the field of commercial launch. It also means the perspective to man-rate launchings, and this represents the political determination of all European governments taking part in the Ariane program. We fully trust the program. We will now prepare the second qualification flight, having fully determined the causes of this incident in order to be able to find the appropriate remedies. On behalf of all the guests here, I would like to tell all our friends in the Guyana Space Center how much trust we set in them. We knew which risks we were running. We will do everything within our capability for the adventure of Europe in space to be on the success path.
C'est sur cette note qui a été donnée par le ministre François Fillon.
This note that we've just heard in the statement of François Fillon that we can continue with the arrival here of V088, who's going to tell us what his impression was and how he analyzes this rather sad event, which nonetheless does leave the door open to success.
When the disappointment has gone by, we'll have to stand up again and continue. We have said this was an experimental flight. A second flight will take place in a few months from now, once the inquiry board has given us their results of their investigations. We need courage, and as far as Belgium is concerned, as Minister for Space Policy, I renew my full trust in the engineers and all the staff concerned.
Well, after these moments of disappointment, the teams will be collecting information and data and analyzing it in order to find a remedy for Ariane 502. The venture continues here in Kourou. There are people who are disappointed. I heard people sobbing, but this emotional phase is over, and we're going to get down to work again so that Europe can lift off again in the third millennium.